Okay, in this question we have an alpha particle colliding into a nitrogen-14. This triggers a nuclear reaction, giving rise to new nucleus, the oxygen-17 and a proton. The first thing we do is to calculate the total mass before and after the reaction. It turns out that there was an increase in mass of this amount. Using E is equals to mc squared, you can calculate that this amount of mass corresponds to this amount of energy. Since it's an increase in mass, this tells us that the nucleus actually gained energy during this reaction. They gained 1.9 times 10 to the power of negative 13 joules of energy during this reaction. So this nuclear reaction involves an absorption of 1.9 times 10 to the power of negative 13 joules of energy by the nucleus. Who is providing this gain in energy? Is the alpha particle's kinetic energy. Alright, so the energy absorbed by the nucleus during the reaction must have come from the loss in Ke of the alpha particle. That's why this alpha particle must have at least 1.9 times 10 to the power of negative 13 joules of kinetic energy. If not, this nuclear reaction cannot occur. Somebody must provide for the required increase in energy of the nucleus. In the last part of the question, we were prompted to the fact that these two nucleus are not stationary after the reaction. Actually, the question does not have to tell us that, because this is something that we can actually figure out on our own. Because before the nuclear reaction, the total momentum was not zero. This guy was stationary, but this guy was moving. So we had a total momentum which was not zero. So after the reaction, they cannot be both at rest, because that would imply a total momentum of zero, and that would violate the principle of conservation of momentum. So in order to conserve momentum, at least one of them has got to be moving. Maybe one is moving, one is not, maybe both are moving, maybe both are moving in the same direction or in opposite direction, but it doesn't matter. The fact is, at least one of them must be moving, and that means there is some Ke for the oxygen-17 and the proton. Now we have to relook this equation here. So besides the energy that's absorbed by the nucleus, we also have the Ke of the oxygen nucleus and also the Ke of the proton. So again, somebody must provide for the gain in Ke of the oxygen-17 and the proton. And this energy can only come from one source, and that's the Ke of the alpha particle. So that tells us that the alpha particle must have an amount of energy that's more than 1.9 times 10 to the power of negative 13 joules, because this amount is only enough to provide for the required gain in energy of the nucleus. But now that we know it must also provide for the Ke of the products after the reaction, we realize that the alpha particle must have more than this amount. Okay, that's it. Ta-ta.